Hello friends, let's write an ionic equation. To write an ionic equation, the basic steps we need to follow. The first step is balance the given chemical equation. That is, which chemical equation is given, that chemical equation we need to balance first of all. If it is balanced, then it's okay, no problem. After balancing the chemical equation, the second step, we need to identify the ionic compound. So, which in the equation, what are the ionic compounds are there that we need to identify. After the identification of the ionic compound, we need to separate the ionic compound into ions. So, ionic compound we need to separate into ionic compounds. That is step 2. The next step is cancel the spectator ions. So the third step, first of all, we need to identify the spectator ions. Spectator ions means the ions which are not involved in the reaction. They are just spectating the reaction. So that spectator ions we need to identify. After the identification of the spectator ions, that has to be cancelled. So that is the third step. So after cancelling out the spectator ions, what are the species left out in the chemical equation that we need to write as it is? If you are writing, then we will get the ionic equation. These are the steps. So let's write one ionic equation. An example is given. The reaction is between aqueous solution of sodium hydroxide and aqueous solution of hydrochloric acid to form aqueous solution of sodium chloride and water. This is the equation given. First of all, we need to check whether the equation is balanced or not. Sodium at the left hand side, only one atom, and right hand side also only one atom. Just we can check once again. Sodium, the next, what is that? Hydrogen, then hydroxide, then chloride or chlorine. I have note here hydroxide. We need not write hydroxide because hydroxide is not present at the right hand side. Therefore, we need to make a change. What is that? The next we can write chlorine. After that, this oxygen we need to write it. So once again, we can rearrange the order. After sodium, the metal, we can write the non-metal, that is chlorine. After that, hydrogen. The next one, oxygen. That is the order. Sodium at the left hand side, how many atoms are there? Only one. Right hand side also one. Chlorine at the left hand side 1, right hand side also 1. Hydrogen at the left hand side 1 plus 1, 2. Right hand side also 2. Oxygen at the left hand side 1, right hand side also 1. So all the atoms on the reactant side as well as the product side are equal. Therefore, the given equation is balanced. Therefore, as a result, we need not balance once again. This is self-balance equation, already balanced. It's a self-balance equation. Therefore, balancing is not required. So we can erase this. So from the balance equation, the next step, we need to identify the ionic compound in the given equation. The ionic compounds are sodium hydroxide. Sodium hydroxide is an ionic compound. Hydrochloric acid is an ionic compound. Sodium chloride is also an ionic compound. So these ionic compounds we need to separate into ions. So I am writing the ionic ions. Ions are being separated now. So NaOH, what are the ions present? Na plus OH minus. Then if we separate hydrochloric acid, the ions what we will get? H plus and Cl minus. The sodium chloride we can separate into Na plus and Cl minus. This water is not an ionic compound, it's a covalent compound. So we need to write this water as it is. We need not separate this. In fact, while we are writing the ionic equation, we need to state the state symbol. That is very important. The state symbol has to be mentioned. The state symbol is mentioned. That is sodium hydroxide we have separated into Na plus aqueous and OH minus aqueous. HCl aqueous we have separated into H plus aqueous, Cl minus aqueous. Sodium chloride we have separated into Na plus aqueous and Cl minus aqueous. And finally, H2O liquid. The next step, we need to identify the spectator ions. The spectator ions we need to identify. That is the next step. Spectator. The spectator, they are not involved in the reaction. They are just watching the reaction. So that only we need to identify. The spectator ions we need to identify. After the identification, those ions need to be cancelled. That spectator ions need to be cancelled. What's the rule? The spectator ions will be the ions which are present on both the reactant side as well as the product side. That ions only we call that spectator ions. The ions which has to be present on both the left hand side as well as the right hand side are called spectator ions. So what are the spectator ions here? Na plus aqueous is present here, and this Na plus aqueous is present at the product side also. Left hand side Na plus aqueous, right hand side Na plus aqueous. Therefore, this is spectator ion, so we can cancel the spectator ion. Any other ions are there? Next is OH minus aqueous. That OH minus aqueous is not present on the right hand side. The next one, H plus aqueous, that is not present on the right hand side. Cl minus aqueous is present both the side. Cl minus aqueous, Cl minus. So the Cl minus aqueous we can cancel it. So these are the spectator ions. The spectator ions are Na plus aqueous and Cl minus aqueous. That we have cancelled now. So after cancelling out those spectator ions, the remaining species are what are the present that we need to write as it is. So what are the species left out? That is OH minus aqueous. OH minus aqueous plus the next, what is the species left out? H plus aqueous gives, here the right hand side, what is left out? Water alone is left out. H2O liquid. Now we have got the ionic equation for the reaction of sodium hydroxide with hydrochloric acid to form sodium chloride and water. The ionic equation is OH minus aqueous plus H plus aqueous gives H2O liquid. Thank you so much for watching.